Hey y'all, today we're going to be covering the second part of 9.5, which is about global climate change. Our learning objective for today is that you can explain how changes in the climate, both short and long-term, impact ecosystems. So it's the same learning objective as last time, but the essential knowledge we're going to gain today is a little bit different. We're going to be looking at ocean currents, how we are going to have like soil and rainfall impacted, how we are seeing differences in the polar regions from other ones, how ice and snow melting is going to be impacting, the positive feedback loops involved in all of this, and some of the consequences too. So we're going to first talk about the impact on marine ecosystems. So as we are getting this temperatures warming and our climate changing, this is going to cause an altered range of marine ecosystems. So we're going to have some new marine habitats are formed by the rising sea level and flooding coastline, which is going to push out some of the terrestrial organisms that were living on land there. But what this is also going to happen is as our ocean is getting deeper, some of the areas of the ocean are going to become too deep to receive sunlight, which means that photic zone, where we're getting certain amounts of sunlight, is going to be shifting up further from the ocean floor. This is also going to alter our ranges for organisms. So warm water holds less oxygen. So many fish populations have declined or they've started migrating to colder waters where there can be enough oxygen to support them. As we are looking here, MSY stands for our marine standard yield, mean standard yield. Sorry, I forgot what the M stands for, but it's our standard yield, like the amount that we are able to fish. And as we are looking here, if we are getting our blue, this is going to be increases in our yield. Red is going to be decreases. As we look, majority of these are moving in the down region. Some of these are like pretty extreme levels. And so what we're seeing overall is that there's going to be changes in the fish populations and what's going to be available for fishermen who are dependent on these fish for their livelihood. So now impact on ocean circulation, which is going to be a bit of a throwback to Unit 4. So in Unit 4, we talked about this thermohaline circulation. And this is the idea that we are having our typical circulation of warm water from the equators. You are also having cold water going down from the polar regions, and it causes a cycling of the waters in our oceans, which leads to dissolved oxygen and different levels of our nutrients kind of being distributed. Now, when we are getting warmer temperatures, this is going to lead to a suppression of this circulation. And so this mixing of salt and nutrients and all the things that are dissolved in it could slow down or even stop altogether. If we look at this diagram on the right hand here, this is talking about our warmer areas. Clearly, majority of this, we are getting warmer temperatures in land and on ocean. Now we're getting a couple of these darker areas. So for example, I'll point out this one up here, like our darkest one. This is going to be in the Greenland area where we are getting melting ice. And so that's going to be cold, but ice is going to be fresh water. So keep in mind that as this is going to be dissolving, it's going to be fresh water, which is less dense. It's going to be sitting on top of the water. It's not going to be going down and getting that mixture in, which is going to impact all of the levels of circulation. It's going to impact the weather. We're going to be getting cold, fresh water built up in the North Atlantic, which is going to be impacting the ecosystems, the weather, the fishing, all of those things. And so it's not going to be sinking down, which typically when we have the sinking, that's part of what starts that circulation, which we see over here, where it's number 1. We're now not going to be getting that because this cold water is going to be sitting on top because it's fresh. So what's going to happen is the Atlantic, this cold slowing, is going to slow these warming waters being mixed. It's going to lead to cooler Europe temperatures and the slowing of the global thermohaline circulation. And so when you're getting these differences in like warm and cold and certain things getting stuck in areas, you're not getting that cycling. You're not getting all of that mixing, which is necessary for continuing to have these healthy well-balanced ecosystems in the oceans, but also impacting like the wind that is moving off of it and the temperatures that are then going to be hitting Europe and all these other places. Now, what we have is unequal global warming in the poles versus the rest. So the polar regions of Earth are warming faster than other regions, and this is known as polar amplification. Especially we see this in the North Pole because the North Pole has more land and less water to absorb excess heat. So water absorbs a lot of heat. It is dark. It is going to have the ability to take on that excess heat, which means that the areas above the water are not going to be as hot. So if we look down here, there's a lot of just ocean down here. And so it is actually staying a bit colder. Now, keep in mind, the oceans are taking on all of that heat, which is not so great. But for the air above it, it is less hot. But when we look up here, this northern region, we have a lot of land, a lot of ice. And so we are going to, end up with this area being a lot hotter because we don't have the ocean to be absorbing those extra levels, which then is going to be leading to the fact that as it's warmer, you're going to have sea ice melting. Now, here comes our positive feedback loop. Remember that ice is going to reflect a lot more of our sunlight, and water is going to absorb more of it. And so as we are getting temperatures rising, we're going to get melting sea ice, which is going to lead to more exposed water, which is going to absorb more sunlight, which is going to lead to more ice melt, which is going to continue. So it's this positive feedback loop going on here. And again, this is going to relate to our tropical heat and our thermohaline circulation, because as it is getting warmer at the poles, then this distribution of the tropical heat we're going to be getting a lot of the warm air coming, but we won't have so much of the cold to push it. And so we're going to continue disrupting this circulation. Now, what we're also going to see, which I mentioned in our last notes, so this is a refresher. You don't even have to rewrite it down if you don't want to, but since it's very related and we're talking about the feedback loops, I just wanted to throw a reminder out here that also not only do we get the ice that's floating on water melting, we're also getting the permafrost melting, which is going to continue to release more carbon dioxide and methane, which is going to continue with that positive feedback loop here. Another thing that we see is as we are having more coal being burned, this adds to our air pollution. We're going to get more soot, and other particulate matter that's making its way into the atmosphere. And because of our circulation of our winds, a lot of that is distributed to the poles, which is going to give us darker particulate matter. It's going to cover our ice, which means our ice is going to absorb even more heat because remember that darker surfaces have a lower albedo, which means this is going to be, it's going to be absorbing more heat, which is going to cause more of the ice to melt. Now, our impact on polar ecosystems, as we have Arctic sea ice being lost, that is going to cause habitat loss. Now, we're going to talk about some of the animals that depend on this. So first of all, seals use the ice for resting, and they also find their holes for breathing. So if we take away the ice, the seals don't have anywhere to rest, which means they're not going to survive. But also one of the things that isn't always as talked about is the fact that algae grows on ice, and algae is the base of the food web. And if you look at this diagram here, one of the things that they say is that Arctic ice is as important to the Arctic ecosystem as soil is to a forest. So if we think about how necessary soil is for a forest and all the things that we learned about the importance of soil throughout this entire class, kind of think about that with the Arctic ice. As we are losing it, you're losing a place for this algae to be growing, which is the base of the food chain, which is going to feed everything above it. Now, also, if ice is gone, we're going to be losing seals. We're also going to be losing polar bears because polar bears use ice for hunting seals. And so it's just kind of this whole interconnected food web that the ice is important for. And when you're getting that habitat loss, it's going to be drastically disrupting our polar ecosystems. And this is going to be your practice FRQ for 9.5. I want you to look at this data here of sea ice from 1984 to now, and I want you to explain how the data above support the hypothesis that temperatures in the Arctic will continue to rise. So think about sea ice and some of that albedo and stuff that we talked about here, and yeah, apply it to this. So it's going to be your practice FRQ for 9.5, and those were your part 2 notes on 9.5 on global climate change.